Hello and welcome back to EdNik School.
In this video I will be explaining the whole concept of D flip-flop, and I will also be providing the contents like circuit diagram, truth table, characteristic table, excitation table and equation derivation. So stay tuned and watch the whole video. Okay, so first of all we will be starting off with the circuit diagram, and this is the circuit diagram that we need to construct in order to build a D flip-flop. As you can see that we will be needing two AND gates, two NOR gates and one inverter aka NOT gate, and this is the clock, and this is how you build up a circuit connection using the ICs so that you can get the D flip-flop. And this is the truth table, and you should notice that in D flip-flop when you have 0 as your input you will get zeros in the output section, which is QT plus 1, and this is a two input table, so you can see that there are like 4 bits. And you should also note that when you have D equals to 1s, then you will also get 1s in the output section. And there's another important thing that we need to keep in mind, that we will be using the truth table in order to find the characteristic table as well as the excitation table. So this is the characteristic table. As you can see, as I have mentioned, that D, when D is 0 you will get QT plus 1 is 0, just like the truth table has mentioned that when D is 0, just like in this case, like when D is 0, it doesn't matter what you have in here. When D is 0 you will have 0 at the QT plus 1 always. So in the characteristic table you have to write down that D0, which means QT plus 1 will be 0 as well. And when D is 1, just like these two cases, and you will have QT plus 1 equals to 1. And this is the relationship that I have stated in here. You can actually overlook this part. We don't need to consider it right now. And this is the excitation table. If you're wondering how I actually build up this table, then you have to go back to the truth table and see the relationship. Like when QT and QT plus 1, when these both were zeros, the D was 0. So QT plus 1 0 0, D will be 0 as well, just like this one. And then when QT equals to 0 and QT plus 1 equals to 1, just like this 0 1, you can see that D was 1 and there is 1. And when QT1 and QT plus 1 is 0, just like this one, like QT equals to 1, QT plus 1 is 0. From this relationship we got D equals to 0, and we put down the 0 in here for D. And when both of these were equal to 1, then D was 1, just like this. Okay, this is the truth table if you remember, and we have like assessed the relationship between these three, and then we finally found the excitation table for the D flip-flop. It's pretty easy. And finally we got down to the equation derivation. Now how do we do that? We have to get back to the truth table again, if you remember that this was the truth table, and we'll be using a K-map just like this. Now note that QT plus 1, we have to like find the ones, where are the ones are, and like this is, you have 1 in the third line or the third row and the fourth row. And in K-map we will be placing the ones in their respective places, and you already know how to use the K-map in order to solve equation for any circuit or anything. So as you can see, the ones are here, and if we take common of these two, we will get the equation equal to D, because this combination is only present at this one. it's not situated in any of these three, so the equation will finally be this: qt plus 1 equals to d. So it's pretty easy, as you can see, and that's it. That's how you actually simplify the whole concept of d flip-flop. And I hope you found this video helpful. If you have any question, let me know in the comment section.